My name is Bastian Krause and I'm working as an embedded Linux engineer at Pengutronics. In this video series, I will show you how to get started with Labgrid. This is Labgrid's GitHub page. With Labgrid, you can remote control your embedded board's interfaces, share boards with your colleagues, no matter whether you are in the office or connected remotely. No physical interaction required. You can run automated tests using PyTest or automate steps you have to do over and over again. Even provisioning your boards is possible. So let's see what that means. This is my desk. As you can see, I'm currently working on an NXP IMX8 evaluation board here. Like most embedded boards, we have interfaces. The power interface, the power is connected to a USB controllable power strip, a serial interface, network connection, and a micro SD card here. We use that to boot from during development. As you have noticed, there is something special about my micro SD card though. I'm using a USB SD multiplexer here. If you are working with embedded devices, you know SD card juggling. Plugging in SD cards into your card reader, writing the image, then plugging the SD card into your embedded board again, trying to find out if it's now booting. There's a better way though. With such a device, you can switch access to the SD card between your embedded board or the host side via this micro USB cable. This can make a huge difference when developing because your development cycles are getting much shorter. Let's try my setup. And even if you do not have such a USB-SD multiplexer, then Labgrid can do a lot to help you in your day-to-day life. Okay, long story short, let's actually test this setup. I've prepared a Yocto image for this board. This is located here. What if we could just write that image to our SD card? On top here, I've already opened the serial interface, and now we're waiting that the copying operation succeeds. Okay, great. Now we can switch the SD multiplexer to DUT mode, which means device under test. That means the device can access the SD card again. And now we could just power the board. Okay, so this is the bootloader handing over to the Linux kernel. And the Linux kernel hands over to systemd. And after a few seconds, we get the login prompt here, can log in. And now we can even go and create an SSH connection to the board. Yeah, and then we have the prompt here. As you may have noticed, I did not need to interact with any devices in /dev. I did not need to know where the board is actually connected, to which USB ports there, to which dev TTY USB something. I did not need to specify the power socket here. So this is a very comfortable way. I will show you during this video how this works and how you can do the same setup at your site. We will set up the infrastructure needed for Labgrid. We will learn how to use the command line client. This is what is called labgrid-client here. And we will show all the basics required to get you going quickly. Let's have a look at what are the components that Labgrid consists of. Labgrid's distributed infrastructure consists of a central coordinator, several exporters, and these exporters have resources, which are just devices connected to the exporter. Devices like the serial interface, or in my case, the USB controllable power strip, or the USB multiplexer device are just connected via USB or some other interface. And these interfaces are defined in a configuration in the exporter, and the exporter knows then which resources should be exported. And it does so by telling the coordinator about it and about the state of the resources. What can a client do? A client can now connect to the coordinator to get the list of resources. It can group these resources into something that is called a place, and a place can then be acquired by the client, and its resources can be used. There are several types of clients. We already saw labgrid-client, the command line interface. There is a scripting interface, and then there is the PyTest plugin, which can be used for testing purposes. For the sake of this demo, we will run coordinator, exporter, and clients on the same laptop, but for setting things up, that should not really matter. We will now start with the basic setup. Let's install the client-side components first. On the right-hand side, we see Labgrid's documentation, which we will basically follow. Labgrid is a Python library, so we want to install the dependencies required in recent versions that are tested with Labgrid, so we use Python virtual environments for that. Start here. I've already installed these Debian packages beforehand, so we do not need to do that. We can just start by creating the virtual env and activating it. So the little env prefix here in the command line prompt tells us that we are now in the virtual environment. Now we clone the Labgrid repository. We are switching into it and installing the requirements there. This takes a short while, and if that succeeds, we can continue with the actual installation of Labgrid. So until now, we only have the requirements installed. That finished. Okay. Now we can install Labgrid inside that virtual environment. Okay, if you are setting up Labgrid in a production environment, you want to read those nodes and follow them. For the sake of this demo, we will skip over them. Now, to make sure everything worked fine, we will see if the Labgrid client command line interface shows its help. Yeah, that's working. We can skip over these things because we do not need one wire SNMP Modbus for this demo. The testing part of Labgrid will be a separate video, so we will do that later. Now we will continue setting up the distributed infrastructure. We will start with the coordinator. Remember, the coordinator is the central place that keeps track of all the resources and the places. We already cloned Labgrid. Let's leave the environment we set up for now. Now we create a separate environment for the coordinator. We call it crossbar venv. We activate it, jump into it. This Debian dependency is already installed here, so no need to do that. And now we can switch back to the Labgrid repository, install the crossbar requirements. So crossbar is basically the coordinator component, right? So this takes a short while. All right. Now we will install Labgrid into this virtual environment also. And then we can start the coordinator by issuing this command. Okay, everything worked out. The coordinator is ready. For the sake of this demo, we will just run crossbar inside this terminal. If you scroll down here in the Getting Started pages, there are also systemd files mentioned. They are located in the Labgrid repository under contrib systemd. You can adjust them and set up the Labgrid components like the exporter and the coordinator via systemd services, but we will not do that in this demo video. Now we will continue setting up the exporter. The exporter is using the Labgrid virtual environment we set up, so we will simply switch into it and do basically the same here. For the exporter, we need to have a configuration. So if we just start the exporter here, it says resources is required. If we do -h for the help text, it says the resource config file name is required for the Labgrid exporter. So we need to define a configuration for the exporter. In order to make use of the USB resources here, we will need this udef rule that is mentioned here. It makes sure that not only a limited set of USB devices get the ID path attribute, but basically all USB devices. So we can use that to reference devices and USB resources, USB ports in our exporter configuration. So this is already installed on this demo machine here. I will first unplug all the USB devices from the hub. So as you can see, I've got this 13-port USB hub here. I've put labels on them so I know which port is which number. This will help us. Okay, now we will use Labgrid Suggest. Labgrid Suggest is a cool tool which, let's just let it run. It basically lists all the USB devices connected to a machine and makes suggestions if we want to export them via the exporter, how the configuration should look like. I've unplugged all the devices, so everything that is listed here, we will not need to export these devices, but we will plug each device now and make a configuration out of them. We will start with the configuration. The configuration is in YAML format. Let's have a look at the Labgrid configuration section. Another thing we will need is the templating that is used here. So it's Ginger 2 templating engine. We can use that to save us from a lot of duplication in the configuration of the exporter. So what we actually want to do here is export each port of this USB hub with all the devices we are interested in, right? So we have the serial port, we have the SD multiplexer device, and we have the USB controllable power strip here. So we want to recognize all of these devices on each port. So we will start with a multi-line Python expression here. We want to iterate over a list of tuples. One, the index, so this is basically what is on the label of the USB port there, and one is the sysfs entry. This will be something like that. So we will iterate over a Python list, like I said. We will have the index and then the sysfs entry, and we will close the tuple here and have that 13 times. Close the list here, have the multi-line Python expression, and for the sake of completeness, we end the for loop down here already, so we do not forget that. Let's start with the first part. The easiest method to do that is using a USB stick, like my Bart Simpson USB stick here, and we will just plug that USB stick in each port while Labgrid Suggest is running. So let's start it. This is the first port, and this is the sysfs path which Labgrid Suggest told us. So this is the first one. Now we will go to the second one, put it into the second port of the hub. So this is basically the easiest because we do not know how the internals in the USB hub work. These numbers you will see at the end. We wouldn't have a way to guess the system behind that without opening the USB hub there. Now we will have a look at how the basic exporter configuration looks like. We always have these group names. In practice, it is always best to specify the actual physical USB hub there. So if we say USB hub minus port something, then we know that if something is plugged into port 7, we can just recognize it there, right? We use the index from above, and this will be the group. Then we can set a location. Let's do USB hub on my desk. And then we have the actual resources. For the resources, we go to the configuration chapter, and then we have the section about resources. These are all the resources Labgrid knows, and yeah, you can just pick what devices, what interfaces you have from here. So we will start with the USB serial port. Right. So the USB serial port is specified as having a match and a speed, but the speed is optional, so we won't need that. Copy this, have the match indented, and then you can just use that. And now we do not want something hard-coded as this one, because we did all the work with the templating here, so we just use sysfs at that place. Now we will have a look how the USB SD multiplexer works. It's called USB SD MUX, so resource name, and then we have the match with the head here. Okay. And now there's something special. We want to have the USB controllable power switch here. This is one physical USB device, but it has 4 sockets, right? This is socket 1, 2, 3, and 4, and we want to have them as separate resources. We need another for loop. Inside our for loop, we want to be on the level, indentation level of the group here, like that, and another for loop that should look like that. We have 4 ports, so we go with in range 1.5, and then end that expression, and do N4. So now we want to have for each of the power sockets or power outlets, we will have another group. So we go with the port index just like above, and then we go with sockets, and then just let us use socket here, not port, so it's getting confusing. So, and this is the socket variable. And now we want to have this USB controllable power strip device. It's called a syspm. It's a driver. We're not interested. We're interested into the port. So this is a resource. The driver, we will talk about that in one of the next videos. So this is the resource. The match looks the same, but there is no add in front of it. So the add is explained in the UDEV section, I think. If we want to scroll down, we can have a look there. So the UDEV matching chapter in configuration says match entries starting with an add are checked against the device parents instead of itself. So there's a catch there. So you have to be sure to use the correct one. Labgrid suggest will also tell you the correct one. So if you just connect that, you will not make a mistake there. Back to the syspm port, the match and the ID pass, we can basically copy from here, remove the add sign, and expects an index. So the index is the number of the socket here. Index is now socket. Now we can do that and clean a little bit up. Okay. Now let's leave the virtual environment here, open a screen to run the exporter in. It's called the screen exporter. Source the environment. So we will use the Labgrid venv for the exporter also and for the client. And then activate. And then we go with Labgrid exporter and then the configuration. All right, now it's starting up, iterating over all the resources it finds, marks them available or acquired. We will detach from the screen session, source the VM once again. Now we will unplug the USB stick. We will not need that anymore. And now we plug in our power strip, USB controllable, our USB SD multiplexer, like that, and the USB serial, like this. All right. Now we can use Labgrid-client resources to see which resources are available. So what do we see here? We see that on port 1 of the USB hub, a USB SD multiplexer is plugged. This is correct. So this is the SD multiplexer connected to port 1 here, right? And then we have the network serial port. So this is the serial port connected here to port 2. This is also correct. And then we have the 4 sockets we can use here, and we have the second socket the MX8 board connected to. So this works like a charm. Now we will create a place. How do we create a place? Let's exit Labgrid suggest over here. Then we will do a labgrid-client -help. And I'll show you. Here are the subcommands, right? And this is the name of the place. So we just do labgrid-client --place. Let's call it MX8, but we can call it whatever we want, right? So MX8, and then we go to the subcommands and we want to create a new place. So we just go and make create. Okay. And now we can add matches. This is the command, and the add match command basically adds resources to that place. So we can simply copy from the output of Labgrid-client resources the resources we want to group into the MX8 place. So we said we want to have that USB SD multiplexer. That works. Then the serial port. And then we said we plugged it into socket 2, right? So it is connected to port 13, the USB controller power strip, and the MX8 is connected to socket 2. So this should be the correct resource. Now we can look at the other subcommands here. We've created the place, so we can go and issue Labgrid-client places. MX8 is the only place we have here. That is correct. And now we want to acquire that place or lock it. Before you can use the place, you have to lock it so nobody else can interact with that and disturb your board state and everything, right? We will Labgrid-client lock that place. And that also makes sure that the resources are correctly set up. So that is checked and that works. So the board is currently powered on, so we can power it off. The socket is turned off now. We can use this one over here to start a serial console. --place MX8 console. And now we can power it on. Okay, and here's the bootloader. We can interact with it. We can power it off again. And that's basically what is required to set up the Labgrid distributed infrastructure. Let's have a short look at the other commands Labgrid-client is offering us here. Let's see, -help again. So at the beginning of the demo, I did not specify the place. If you remember that, what I did instead is Labgrid understands a set of environment variables. So if you do labgrid, so LG_place and do MX8, then you can basically do all those commands without specifying the -p or --place. So this is a convenience feature. I did not specify the --place option in the last Labgrid-client commands either, because the environment variable lg_place was already set there. So another interesting command is labgrid-client monitor. If we type that in and hit enter, nothing is happening. But if we then unplug a USB device like that, we see that the resource changes from available true to available false. And if we plug it into, I don't know, port 8, then we see, yeah, port 8 of our USB hub. There is a USB serial port connected and it is now available. That's basically interesting if you want to get a feeling of your Labgrid infrastructure. But let's plug it back into port 2 because that's where the MX8 place expects it. That's it for today. Have a look at Labgrid's documentation. It's a link here on the top of the Github page. If something's not clear, feel free to open an issue here. The command line interface is just the beginning, so there will be more videos and ways to use Labgrid. Next time we'll have a look into Labgrid's automation. We will see how to bring the board in a well-defined state in automatic fashion. And until then, take care and bye-bye.